All right, y'all. So like I said, 9.1 is going to deal with the composition of functions. All right, so I'll give you the definition of this, and then I'll show you there's two styles that we look at. So the composition of functions is when one function is used to replace the variables of another function. Okay, so basically, instead of putting in a number for those variables, if they don't give me a number, I'm going to have to put that whole function in for those variables, okay? Now, there's two styles we'll look at. First, we got f compose g of x. Now, that's not a zero or a O. That's looks like a little degree symbol, but that's what we call a composition operator. And that basically lets me know that I'm dealing with a composition, okay? Now, when you see it like this, f composed g of x, that really means f of g of x. Okay, so what this means, y'all, x is the variable of the g function. If they gave me a number here for this x, I would put that number into the g function. Once I got that answer, I would put that into the f function. So when we do some examples, they'll give me numbers to start, and then for the last couple, they're just going to give us variables there, okay? Now the second style, they reverse it, and we'll be doing a g compose f of x. It's the same thing except the order's opposite. This is the same as g of f of x, which means I would start with the f of x function first. Once I got that answer, I would put it into the g function, okay? Almost like you're doing order of operations. You're going to start with your innermost parentheses and work your way out. So I'm going to do two examples using numbers, and then I'll do two examples where they're just giving us variables, and we got to do domain stuff, okay? So the first two, they're giving me numbers as my replacements. So this one's going to say let f of x equal negative 5x minus 1, and g of x is going to equal x squared minus 2. So for this one, they want me to find f compose g of a positive 2. So they gave me a replacement value on this one. So what this is the same as, using this notation, it would be f of g of 2. Okay? So with this problem, I'm going to start by putting the 2 into g of x. The answer we get from that will go into our f of x. So these are two-step problems. The 2 was going to go into my g. I'm going to get that answer, and then I'll plug that answer into my f. So we're going to put a 2 in for the x squared minus 2 here. We're going to figure that out, and that answer we're going to put into f, okay? So that means the very first thing we're finding is this right here. We're finding our g of 2. All right, so to find g of 2, we're going to put a 2 in for that x right there, y'all. So that's going to give me 2 squared minus 2. All right, y'all, so what do we get out of that? Work that out and see what we get, because whatever we get out of that is going to go into my f equation. Um, so what do we got? 2 squared is what? 4. And 4 minus 2 gives me a 2. So since g of 2 was 2, my second step is to find f of that 2. So that 2 is going to go right into my f equation. Well, here's f. It's negative 5 times our 2, and then it's minus 1. So y'all, let's figure out that. Once we figure that out, we will have our final answer. So negative 5 times 2 is what? Negative 10. And then I got negative 10 minus 1. What's that? Negative 11. Negative 11 is what Math Lab is looking for on that, okay? Hey, also, you can almost read these right to left. 2 went into G, and then that answer went into the F, okay? So if I'm going the other way, G of F, that means we'll do the F first. And once we get that answer, we'll put that into the G. And that's what we got coming up here, y'all. We got one that's going to go to G of F instead of the F of G. Okay? All right. So one more with numbers here. I also, for this one, we're going to be given f of x equals 3x plus 1, and g of x is going to equal x squared minus 3x minus 6. All right, so let's see. They want me to find G compose F of a positive 3. Now, if I was writing this out using f of x notation, this one would be G of f of that positive 3. So what are we doing on this one? First, we're going to put 3 into f of x. The answer I get from putting 3 into f of x, I'm going to put into g of x. Okay, so once again, a two-step problem. So first, we're working the innermost parentheses, which is that f of 3. So f of 3, I'm going to take the f equation and put a 3 in for that x. So that'll give me 3 times 3 plus 1. All right, y'all, let's see what that gives me. 3 times 3 is what? 9. 9 plus 1 gives me a 10. So since f of 3 was 10, we're now going to put 10 into the g equation. So I'm going to find g of 10. So here's my g equation. So that's x squared, so that'll be 10 squared minus 3 times 10 minus 6. All right, so let's see what we got. 10 squared is 100. So I'll work this one out a little bit. That'll give me 100 minus 3 times 10 is 30 minus 6. All right, also 100 minus 30 is 70. 70 minus 6. Oh, what's that, like 64? Final answer. Okay, you also two steps. Plug it into your innermost function first. Get that answer. Plug it into the outermost function. Now, y'all, these next two that I do, they're going to change the game up a little bit. They're not going to give me numbers to put into these ones, okay? But look what they want on these next two examples I do. On this one, they want me to find f of g of x and g compose f of x. So they want me to find both plus the domain of each. So these will start at your number 4, okay? So look what they're giving me for this one. F of x equals x plus 3. And g of x is going to equal 2x squared minus 5x minus 3. So this one will be really similar to y'all's number 5. So what I'm going to do, I'm going to work it first and find by f of g of x. Then I'll work it and find g of f of x. Once we found both of those, we'll find our domains, okay? So over here, I'm going to find f of g of x. So remember, that is f of g of x. Now look here. They did not give me a number to replace these x's with. So what I got to do for this one, since I don't have a value to put in for the g of x, I'm going to take the whole g of x function. I'm going to take the whole function and put it into the x's of f of x. So I'm going to take the g of x function and put into the x's for f of x function. Okay, so if I do that, I'm finding f of g of x, like we said. That's going to equal my f equation, which is x plus 3. In place of that x, I'm putting this whole function. So that's going to give me a 2x squared minus 5x minus 3. So all of this right here just became that x. Now after the x, we still got a plus 3. So see, y'all, that's what I'm talking about. You're putting a whole function in for that variable. So let me ask y'all this. Can you do anything else to that? Is there anything y'all can do to simplify that thing right there?
You can make the threes cancel out.
I can make the 3's cancel out. Good job. And y'all doing that, that looks like I'm going to get what? 2x squared minus 5x. So this right here is what MathLab wants for that first answer. All right, now let's find our g of f of x. That's going to be like g of f of x. So what am I going to do this time? Since I can't do nothing with that f of x, I'm going to take the f of x function and put into the x's of the g of x. I'm going to take the f of x function and put into the x's for my g of x function. So you take this innermost function and put it into the other. All right, so that's going to give me my g of f of x. So y'all, here's my g function. So look what I'm doing now. So let me get a different marker here. So what I'm doing now for this one, I'm taking this x plus 3 right here. I'm going to put it in for that x, and I'm going to put it in for that x. Both of these x's were going to get replaced with an x plus 3. All right, so that's going to give me 2 times x plus 3 squared minus 5 times x plus 3, and then at the end is a minus 3. All right, so it looks like I need to do a little foiling here first. That x plus 3 squared. So what I'm going to do is bring down this 2. It's going to multiply by whatever I get when I FOIL that. And I'm just bringing everything else down. So y'all on the side here, let's FOIL x plus 3 squared. That's going to be x plus 3 times x plus 3. All right, so x times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. Add your like terms, and that's going to give an x squared plus 6x plus 9. I'm going to replace that right here. All right, so next I'm going to distribute a 2 here and a negative 5 here. So that's going to give you 2x squared. 2 times 6 is 12x. 2 times 9 is 18. All right, distribute a negative 5 here. Negative 5 times x is negative 5x. Negative 5 times 3 is a negative 15. And then at the end, bring down that negative 3. So it looks like all we got to do, y'all, is add like terms and be done. So I got my 2x squared. Oh, y'all, how many x's do I got? Let's see. I got 12 x's here. Negative 5 x's. So 12 minus 5 left us 7x. All right, then let's see. We got an 18 minus 15 is 3. Oh, and y'all look at that. 3 minus 3 is 0. So the numbers all cancel out. So our final answer is 2x squared plus 7x. All right, I'm going to come up here and do the domain. Now, the domain for these, we're going to write it in interval notation. I'm going to start at negative infinity, exclude any numbers if I got to, and then I'm going to go off towards positive infinity. So my first question, here's f of g of x. And you ended up with this. During this process, are there any numbers y'all would have to kick out of your domain?
Would you do 3 and negative
Well, those ones canceled,
3?
um, but those didn't make anything undefined or anything, right? So if y'all remember, what's the only thing I'm worried about on my domain? Well, it was fractions, wasn't it? The only thing I was worried about on my domains were fractions. And that's because the bottom of a fraction could not equal zero. Well, y'all, I don't see no fractions here. So since I don't see no fractions, my domain is going to be negative infinity all the way to positive infinity. No fractions means no numbers have to get excluded. So what about down here on this g of f? Let's do its domain. Well, here's where we was working it. But no matter what step you go on, you don't see no fractions. So since you don't see no fractions on this, my domain for that one is going to be negative infinity to positive infinity. Remember, y'all, when we're doing domains at this point, we're only worried about fractions and we're only worried about that denominator, okay? If you don't have a fraction, we're going to say that it's good for all real numbers. And that's negative infinity to positive infinity, okay? Now, don't worry, they're going to give us a fraction because the next one I'm going to do is going to deal with those fractions, okay? All right, so for this example, I'm going to find f of g again and g of f and the domains of each. Okay, so same thing, but y'all look at this. This time they're giving me f of x equals 3 over 1 minus 5x. And my g of x is going to equal 1 over x. So I'm going to do my f of g here, my g of f here, and then I'll do my domains, okay? All right, so let's see what we got. First, let's do f of g of x. Remember, f composed g of x is like this. F of g of x. So y'all, what that means is we're going to take the g of x function, then the g of x function is 1 over x here. We're going to take this whole function here and we're going to put it into that x on the f function. So that's going to give me a 3 over 1 minus 5 times that 1 over x. Okay, so we took the g, we took our g and put it into the f. Well, y'all, here's my g, 1 over x, and it's now in my f equation. Y'all, at this point, what can this x not equal? So right off the bat, this x right here cannot equal what?
0.
Oh, Carlith, I think you got it up there, right? You got what, a 0? Good job. X cannot equal 0 at that point, y'all. Right, so that makes it undefined. So that's one number I got to kick out of the domain on f of g is that 0. Now let's simplify it and see if there's any more numbers we got to kick out. So on this thing first, you're going to multiply that 5 times that 1 over x, and I'll make the 5 look like a fraction by putting a 1 under it. So on top, I'm going to have a 3 over 1 minus, well, y'all multiplying straight across, 5 times 1 is 5. 1 times x on the bottom is x. All right, so what you want to do, since this is what we consider a complex fraction, we want to get rid of this x off the bottom of this 5. So what we do at this point, we're going to take the top and bottom, and we're going to multiply everybody by that x. Now, the reason I'm multiplying everybody by x is because what happens to these x's right here on that 5? You got an x on top, x on bottom.
Does
Oh,
it
I didn't hear
cancel
you,
out?
Angie.
Do they? Okay, yeah.
They cancel. I thought that's what you were saying. Now, on the top, you got a 3x. On the bottom, you now got what? X times 1 is x minus, well, all them x's canceled, so all that's left is a 5. All right, so that's all I can do on that in simplifying. Let me ask y'all this. What can this x not equal?
0?
Well, this whole thing can equal 0 down
Equal
here.
5.
So yeah, it can't be a 5. Good job, y'all.
Let's see, positive 5. Yeah.
Yeah, because 5 minus 5 will make that 0. So we know now that x cannot equal a 5 on that one. So when it asks me for the domain, I got to exclude the 0 and the 5 on that one, okay? All right, so what it'll do now is make you do the g of f. Well, g of f is going to be g of f of x. So y'all, what that means is you're going to take this f equation, you're going to take the f and put into the g. We're going to take all of this and put it in for that 1x. So that's going to give me a 1 over all of this, which is a 3 over 1 minus 5x. All right, so we're going to have to do a little bit of work on this and then figure out what that x cannot equal. So since this one's got a 1 minus 5x, to figure that one out, you would set 1 minus 5x equal to 0. What's that going to do? Subtract 1 from both sides. I get negative 5x equals negative 1. And then I want to divide by that negative 5. So y'all, that'll cancel, giving me an x. And those negatives will cancel, making that a 1/5. So at this point, we know this x right here cannot equal 1/5. Because 1/5 times 5 is 1. 1 minus 1 would make that 0, okay? All right, so I'm going to show you a different way to simplify this one than I did this one, okay? Because this one's different. You don't have a fraction of this form. We got one like this. So what I'm going to do is rewrite this as 1 divided by 3 over 1 minus 5x. So y'all remember the rule about dividing by fractions? I'm going to bring down that 1. We change from division into multiplication. So y'all, what do? If you change from dividing a fraction into multiplying, you're going to take the fraction and flip it. So that this will become a 1 minus 5x over 3. All right, so let me pull this and separate that just a little bit there. And then 1 times that is going to be that. 1 minus 5x over 3. Now, let me ask you this. Up here, we said this x could not equal 1/5 because that made it undefined. Same thing. Are you worried about any numbers on this bottom fraction? Do you have to exclude any numbers from this final answer we got? Well, y'all guess what? Do y'all see the variable in that denominator? There is no variable in the denominator. So y'all, there's no way you can turn this 3 into a 0 because we don't have a variable down there. So we don't have to exclude any numbers off of this fraction. So all we got to worry about on this one's domain is the 1/5. All right, y'all. So let me write the first domain and then we'll do our second one. All right, so for this domain, it's going to start at -infinity. And let's see, we're excluding a 0 and a 5. So the first number I'm going to hit is 0. So I'm going to union around 0 until I get to the 5. Then I'm going to union around the 5 till I head off towards positive infinity. For the second one here, you only had to cancel out one number. That was that 1/5. So the second one will go from -infinity to 1/5. And then union 1/5 to a positive infinity. And y'all, those ones, they actually give you answers with those they actually give you the A, B, C, D. So you just got to choose the domain that matches your question, okay? All righty, y'all. So that is the composition of functions. If they give you a
Can,
number, put it
can you give
into,
me
say
can you
again.
give me 1 second to copy this down before you switch the page?
Oh, yeah, I'm just rambling on a little
Move.
Okay.
Oh, like what?
Yeah. So composition, I put one function into another function for its variables, okay? If they gave me a number, I put the number into the first function, figured out what it gave me, and then put that answer into the first one, okay? So they're a little tricky at first. But what this is this is getting you ready for science. Like say if you got a formula, force equals mass times acceleration, and then you have another formula for the acceleration equals whatever. Well, to work this function, you have to figure out the A first. So you'd plug in, get A. Once you know what A is, you would put that answer here, multiply by your mass, and get your force. So that's what this stuff is sort of getting y'all ready for, okay? So y'all, let's see, 9.2 is a little different than this 9.1 was, okay? So y'all, 9.2, it's going to deal with inverse functions. So to me, inverses are like opposites. Like adding has an opposite, subtracting. Multiply has an inverse or an opposite of dividing. Exponents are opposites of square roots and stuff like that. Okay. So for the first example here, before we get into functions, they want us to find the inverse of the relation. And the relation I have is going to be a set of ordered pairs. So my set of ordered pairs is going to be 3 comma 2, 1 comma negative 1, 8 comma negative 4, and finally 5 comma negative 5. So if they give you a set of ordered pairs and you want to find the inverse, all I'm going to do, y'all, I'm going to switch the x and y values for each ordered pair. Okay? I'm going to switch the x and y values for each of these 4 ordered pairs. So here comes the answer. MATLAB's going to give you the little curvy squiggles. You got to put all the ordered pairs and then put all your commas and all that fun stuff. Well, it says switch the x and y values. Well, here's my x and here's my y. If I switch that, that's going to give me a 2, comma 3. If I switch this ordered pair, I'm going to get a negative 1, 1. I switch this, I get a negative 4, 8. And y'all finally, switching the last two, I get a negative 5, 5. Final answer. This is now the inverse relation because I switched all of my x's and y values, okay? So the inverse is probably not as bad as that composition stuff, okay? All right, let's see what we do here. This one says find an equation of the inverse relation. Similar to this one, except they're giving me a little equation versus these ordered pairs. So they're giving me x times x cubed times y equals negative 5. But y'all, what's neat is I'm going to do the same thing. I'm going to switch the x and y variables. Now, I don't move the exponent. I'm just going to switch the x and y around, okay? That's all I do to find my inverse equation or relation. So if this is an x cubed y, my inverse will be a y cubed x, and that's going to equal a negative 5. So the thing they want y'all to realize, to find inverses, whether it's a relation, whether it's this equation, to find the inverses, all I'm doing is switching those x's and y's around, okay? Now, since we're getting into functions now, inverse functions have to be one-to-one. Now, a one-to-one graph is sort of similar to the functions. You remember back in first test, we said a function was a relationship in which all the x values had one and only one y value. And I used a vertical line test. Remember, I could draw a vertical line on my graph. If it intersected it more than once, it was not a function. Well, y'all, one-to-one is similar to that. But what it means to be one-to-one is each y value, not x values now, each y value can have one and only one x value. So the x's can only have one y value and the y values can only have one x value, okay? So to check to see if a graph is 1-to-1, we use the horizontal line test. So the horizontal line test. So the horizontal line test. So your horizontal lines are going to go across left to right. Okay. So what this test tells me, if a horizontal line intersects a graph more than once, then the graph is not 1-to-1. Okay, y'all, so let me show you one that would be 1-to-1. Say, here's my x's and my y's. Say I had a line that just went straight up and down. A little uphill line. But look, anywhere that I put me horizontal lines, it's only going to intersect once. No matter where I draw it, it only intersects it one time. This is what would be 1-to-1. Okay? So that means all these y values only have one x value. Okay? So I'm going to pull up some pictures here or draw some, and we're going to determine if they're 1-to-1 or not, okay? So I'll do a couple of these. There's like 4, so I'm going to do 2 of them. And we're just going to determine if the graph is 1-to-1. So let me do a couple here. So this one I'm doing is f of x equals 2.1 to the x. Now this graph didn't do the whole thing. It just did a little bit. It's got an x here and a y. Now this little graph sort of comes up slowly to the right. Now we'll learn about these exponential graphs next week, okay? But the question is this graph 1-to-1, yes or no? Good job, Charles, because if you draw them horizontal lines, it's not going to intersect me more than once anywhere on it. So good job. That is definitely a yes. All right, let me see what y'all do to this one. All right, oh, y'all, I'm going to draw an upside down parabola. But the question is this graph 1-to-1?
No.
No, y'all, because like you said, if you shoot them horizontal lines, it's going to hit it here and here on a whole lot of this graph. So that would make that a no on that one, okay? All right, so like I said, they'll give you a few where you got to just look at the pictures just to determine if they're one-to-one. Okay? That's getting us ready for this next section. So we found inverses of a relation. That was those ordered pairs. We did a little equation there where we switched the x and y. But y'all, what we're really worried about is finding the inverse of functions, okay? So what better thing to do than to break out those functions? So we're going to be finding the inverse of a function. Now remember, a function will come in the form of f of x. Okay. Now, for a function to have an inverse, that means the function must be one-to-one. Now, y'all, I'm going to tell you this. These start at number 7, and I think from 7 to 12, you're going to be finding the inverse functions. Every single one of those will be one-to-one. So do not check on the B part on that, because B says, no, the function is not one-to-one. But y'all, like I said, every single one of those will be one-to-one. So you got a few steps you're going to do to find that inverse. And y'all, what I'm going to do over here, I'm going to work a problem out with you while I go through the steps so you can see what I'm doing here, okay? So I'm going to do f of x equals x squared plus 2 when I write my steps. So y'all, the first thing I'm going to do, I'm going to replace f of x with, well, let me ask y'all this. What variable is the same thing as f of x? When y'all were graphing, the very first section we graphed, we had one variable equal to function. And then a few sections later, well, we said, well, we can use f of x instead of that variable.
Is it y?
It is definitely a y. So my first step I'm going to do, I'm going to replace the f of x with a y. So over here, this is going to become y equals x squared plus 2. Okay, well, let's think what we're going to do next. When I was finding those inverse relations in those inverse equations, what did we do to find those inverses? Oh, Carnitha, good job. We switched the X and Y's, y'all. So we're going to do that here. We're going to switch the X and Y variables. So if I switch this X and Y variables, that's going to give me an X equals Y squared plus 2. See, it was Y equaled X squared plus 2, but now it becomes X equals Y squared plus 2. All right, y'all, at this point, you're going to solve for y. We're solving this for the new y. Okay, so for my example, if I was going to solve this for the y, my first step would be to subtract 2 from both sides. So that's going to give me x minus 2 equals y squared. So y'all, how can you turn this y squared into a y? How did we turn those x squareds into x's in them problems from the last section?
Didn't you do the square root?
Square roots. There you go. So I'm going to do square root of x minus 2 equals a square root of y squared. Oh, y'all square root of y squared like y'all said was y. You can't do nothing for this one. So that's going to stay square root x minus 2. All right, so for my last step, since I got it solved for the y, I'm now going to replace y with f inverse of x. So when you see this f negative 1 of x, although it looks like an exponent, it just represents that this is an inverse function. So this is inverse function notation. So that means that my final answer, now MATLAB will actually give you this. All you're doing is putting in your final answer, which was the, what, square root of x minus 2. Okay, so that's it. Replace f of x with a y, switch x and y around, solve for that new y. So that's what we did here, subtract 2, then we did that square root. Once we got it solved for, replace that y with f inverse of x notation. So my f of x was x squared plus 2. My inverse is square root of x minus 2. You'll notice a lot of opposites on here. If the function was adding, the inverse will be subtracting. If the function was squaring, the inverse will be square rooting. If it's cubing, you'll cube root. They always undo each other, okay? So y'all, let's work. I got one, two. I got about 5. I'm going to work out of that section. Okay. All right. Now these will say determine if 1 to 1. If 1 to 1, find the inverse. And y'all, like I said, they're all going to be 1 to 1. Okay. So this one will be like number 8. 7 and 8 are really similar. So 8 was harder. So I'm going to do this one. F of x equals 6x minus 2. So start out by saying yes, 1 to 1. You can graph this if you want to. This would be a uphill line going like that. And if you do all your horizontal stuff, it would be 1 to 1 perfectly. So since it's 1 to 1, we're going to find that inverse. So the first step, I'm going to replace the f of x with the y. All right, I've replaced f of x with the y. Guess what we're doing next? We're going to switch the x and y. So you're going to get x equals 6y minus 2. All right, now, so since I've switched x and y now, solve for that y. We ought to solve for this. I'm going to add 2 to both sides, first step. So look at that. That's going to give me an x plus 2 over here. But y'all, over here, the 2's cancel. All that's left is a 6y. All right, y'all, one more step, and then we'll have this one solved. So it looks like we're going to divide both sides by that 6. All right. Well, y'all, we cannot do nothing to this side, so that's going to stay at x plus 2 over 6. But over here, the 6's make it 1, so that you end up with a y. All right, so we now solved it for the y. My last step is to do the f inverse of x notation, and that's going to equal x plus 2 over 6. So I switched, well, not switched, I replaced my y with the f inverse of x notation. And like I said, y'all, MATLAB is going to give you this. All you do is put in the function that you got, okay? So look at this. The 2 was being subtracted. It's being added on my inverse. The 6 was being multiplied. The 6 is being divided on my inverse. You're always going to see opposites on those. All right, y'all, let's get number, I'll do one like y'all's number 9 next. So my number 9 has f of x equals 9 over x plus 6. So yes, it's 1 to 1. Which means we're going to find the inverse. Now, I'm not going to write the steps out every time because I did them on the first 2. I'm just going to do what we got to do. We're going to replace f of x with a y. Because you'll see it's the same repeating pattern, right? I'll replace f of x with a y. Then we're going to switch the x and y. At this point, we're now going to solve this for the y. So y'all let me put it this way. On this one, your first step, we can't solve for the y while it's in the bottom of this fraction. So we need to eliminate the bottom of this fraction. And to do that, you're going to multiply both sides by the y plus 6. Now, the reason I did that, look at this. That is going to cancel with that. All that's left over there is a 9. Now, on this side, you're going to have the y plus 6 times x. Now, I'm not going to distribute that x because my goal is to get this y by itself. So since the x is being multiplied by this, my next step, I would divide both sides by that x. Because look here, those x's cancel. The x's cancel. All that's left is the y plus 6, which means we don't even need parentheses now because that's all that's left. And over here, you got 9 over x. So y'all look what happened. All these steps that I did, all I did was I flip-flopped these. The x was on top, it went to the bottom. The y plus 6 was on the bottom, it went to the top on the other side. So if something's on top on one side, it becomes the bottom on the other side, okay? And then vice versa. All right, so y'all, I've got my chat going. What's the final step to get that y by itself?
Subtract the 6.
Subtract my 6. There you go. All right, so y plus 6 minus 6 is just going to leave my y here. And these are not like, don't have a like denominator or nothing, so I'm just going to leave that a 9 over x minus 6. All right, we're not going to do nothing else with that except replace that y with our f inverse of x notation. And that'll equal 9 divided by x minus 6. So that one's a little tricky, y'all. But y'all are going to be really similar to this one, okay, as you're working it through. All right, number 10, I wanted to give y'all one of these. F of x equals x cubed minus 8. So y'all, yes, it's going to be 1-to-1. This cube one, if you was to graph it, it would look like that squiggly line that went down, sort of goes uphill left to right when we did the cubes, remember, in section 1. But that horizontal line is not going to intersect it anywhere more than once, okay? So, here we go. Replace the f of x with a y. Switch x and y. So x will equal y cubed minus 8. All right, y'all. So what you want to do is get this y cubed by itself first. So let's add 8 to both sides. So look what you get. You're going to get an x plus 8 over here. That's going to equal a y cubed. So y'all, let me ask you this. How can I turn a y cubed into a y? So y'all, it would be similar to what y'all did with the y squared.
Square root it.
Is it a cube root?
Cube root, perfect. So it's really similar, but whatever the exponent is, that's the root you're going to do to both sides. So good job, y'all. You're going to cube root this one. A cube root of x plus 8 will equal a cube root of y cubed. So remember, if you see a little square root like that, it's understood to have a 2 there. So that's why we do square roots to the x squareds. But y'all, if you got a 3 here, you need a cube root, because those are sort of going to cancel each other out, and all it's going to leave is a y. On this side, we can't do nothing to that, so that's going to stay a cube root of x plus 8. Now, I will say this on MathLab, to put this in, it'll have a little radical down there in the answer box with a blue box here. You choose this one, put your 3 in, and then arrow underneath, and then you'll put your x plus 8, okay? All right, y'all, last step, change that y to the s inverse of x. And then that'll equal a cube root of x plus 8. I sort of like this section because y'all see more ways to solve equations like y cubes, the x squareds and stuff from earlier. All right, so y'all, I'm going to do 2 more of these. So let's do a number 11. So my number 11, they're giving me f of x equals 5x squared plus 2. And then it's got a comma. X has to be greater than or equal to 0. Now, y'all, the reason they're saying that is if you were to graph this graph, remember, that's the x squared. So that would be a parabola sitting here like this. Well, if you look at it like this thing is not 1-to-1. But look at what they're saying here. They're restricting your domain. They're saying we're only looking at the graph where the x's are greater than or equal to 0. Well, 0 on the x's is right here. So we're only concerned with this part of the graph. We're not even looking at that part of the graph. They want this from x greater than or equal to 0. Well, if you're only worried about this part of the graph, this part is definitely 1 to 1. So they can restrict the domain to make them work, okay? So notice, we're not even worried about that part of the graph. Okay, y'all with me on that? So we don't care about this. All we're worried about this problem is right here. So we're going to have f of x equals 5x squared plus 2. So y'all, I've done about 3 or 4 of these. So lead me on. Now let me show you this. On this answer, they got this much of the answer already. They got a square root with a box like that divided by a 5. They're giving you that much of the answer. What we got to figure out, what's going in that box, okay? So to get that answer, what's the first thing you're doing to this right here?
Change the f of x to y.
All right, y'all, next step.
Make it x equals 5y squared plus 2.
Good job. Now, we got to solve this. So you're going to get the 5y squared by itself first. So since that 2's being added, you're going to come in and subtract 2 from both sides. So here you get an x minus 2. That's going to equal your 5y squared. Now, y'all, I would do one more step before I did my square roots. Because I want that y squared to be a 1y squared.
Yeah, you divide by 5.
Okay, so let's do that. So that's going to give me, an x minus 2 over 5. That's going to equal y squared. So I'm pretty much, it looks like I almost know what's going on in that box. But to be sure, what's your last step here? Turn my y squared into a y.
It is the square root for both sides.
Okay, so square root x minus 2. Oh, look at that. That thing is about to look perfect, right? We got everything we need. So we know now what we're going to put in top of that. Square root of y squared is a y. So y'all, what are you putting into the box?
X minus 2.
X minus 2. That's it. Okay. No, they're not too bad. It's just like this. I started with an x squared. We ended up with square roots. They were adding 2. We were subtracting. They were multiplying by 5. We were dividing. Look for all those counter moves on those, okay? So y'all, let's do one more and then we'll be done. F of x equals a square root x plus 4. So y'all got to tell me what to do again.
Turn f of x equal into a y. And then do x
Okay, so do that.
equal.
Now, let me tell y'all a little trick on this one. You cannot subtract 4 from both sides. That 4 is under that radical. So we cannot do nothing to that 4. What I need y'all to do before I can do anything is y'all got to get rid of that radical. So since that's a square root, how can you get rid of that square root? Oh, I didn't hear that.
I have no idea.
Oh, hold on. Carnithia, you got it. Look at that. Carnithia got square it right there. That's what we got to do, y'all. We got to square both sides. So that we come in, we're going to square the x. We're going to square the right side also. Because remember, if radicals undo exponents, exponents undo radicals. So if this was a cube root, I would cube both sides. So y'all with me? So here we got x times x is x squared. When you square that radical, it sort of cancels it. All that's left is the y plus 4. So y'all remember that. Exponents undo radicals. Radicals undo exponents, okay? Y'all got one more move and we'll be done.
Subtract the 4.
Okay, so we're going to what? Subtract that 4. Y'all, I get an x squared minus 4 equals my y. I'm going to replace that with f inverse of x, and I get an x squared minus 4. So they start out with a square root. I ended up with a square. They ended up with a plus 4. We subtracted 4. So get familiar with those opposites happening, okay? And you'll be fine with this section. All right, y'all. So next week will be 9-3-9-4. The week after, 9-5-9-6. And then our week 15 will be the last section and test 4. So y'all realize we are on, well, this finished week 12 up, okay? So 12 weeks down, we got about 4 to go.
Are we gonna have like a final exam?
Oh, yeah. So the final exam, our final exam is 25 multiple choice questions. But it is over the whole year, okay? So basically almost one question from section. But it's an easy test because it's multiple choice. So you can work it, look for your answer there, and then pick that answer and move on, okay?
I didn't catch that part about the test. Could you go over that again, please?
On the final exam. Oh,
Yes, sir.
okay. So I went through the weeks first. So next week will be week 13. Week 13, we got 9.3, 9.4. Week 14, we'll do 9.5, 9.6. Week 15, which is basically the last week of lectures, we'll do 9.7 and test 4. And then the very last week is 16th, is what we call finals week. That's when we'll do our final exam. I think it's due by May 10th or something like that. But the final exam will be 25 multiple choice questions.
From the whole semester or the
From
last
the whole
section that we
semester.
covered?
No, from the whole.
Okay.
No, test 4 will be over test 4 stuff that we're doing now. This final exam is comprehensive. So it'll have questions from doing the functions from first test, the XYZ systems of equations. It's going to have a little bit of everything, okay? But hey, we're going to study for this thing really good. And y'all are going to be able to knock it out because, like I said, once you go through it and practice it, you sort of see how the answers are, and it's not bad, y'all. I usually have people do better on that test than any of them. And remember this, the score I get on your final exam, I'm going to replace your lowest test score with whatever grade you get on this, provided it's higher than the low test score, okay? So that means, say you did good on 3 of my tests, but you bombed on one of them. So you made a 50 on one of my tests, but you made an 85 on your final. I will replace that 50 with the 85 that you got on my final, okay? So that's one thing I do at the end. I replace the low score with the final exam grade. And I drop the 2 lowest homework grades out of your score and stuff like that, okay? All right, y'all. So let me stop my share so I can get my video going. Get that thing